Here in question 7, we're looking for a mechanism for the reaction that's drawn. And this question is actually similar to where we started on this exam in question 1a, that we have the reaction of two carbonyls in the presence of a base. So once again, we're looking at an aldol condensation. This one, however, is different in that our ketone is going to be able to form an enolate. Again, we don't have to worry about selectivity. Benzaldehyde has no alpha hydrogens and therefore will be the electrophile. But in our first step, as with any of these reactions, our base will remove an alpha hydrogen and form an enolate. The enolate will then do nucleophilic attack onto the aldehyde. I'm just going to abbreviate to make this easier. Both aromatic rings is pH. So there's what's left of our aldehyde. There's our new carbon-carbon bond. And then we have the remaining carbons that come from the ketone. And so this is our initial intermediate that we form. And again, the new bond that's being formed by the aldol reaction is the one we've put in red. So we know in the next step that O- will pick up a hydrogen to form the alcohol. And then from here, we get our elimination to form the alpha-beta unsaturated ketone. However, remember, in an aldol condensation, it's not an E1 or E2 mechanism for the elimination. But in fact, the elimination goes by the E1CB mechanism. And so the base hydroxide will remove an alpha hydrogen for the second time to give us a new enolate. And then that new enolate will shift electrons, kicking out the OH group to give us the final product.